Ladies and gentlemen, a very warm welcome to each one of you present here. I am Sohani Balchandani, a junior core member at ISTE-VIT, and it is my pleasure to serve as your host for today's event. Indian Society for Technical Education is a non-profit technical student chapter that plays a pivotal role in organizing a diverse range of technical events and fostering a strong technical community. Through engaging initiatives, we aim to uncover and nurture the hidden talents in students, providing them with the platform to excel and make meaningful contributions to the technical landscape. We host a plethora of events, one of them being the Horizon, a national level technical summit which includes a series of workshops across various domains like web development, machine learning, electronics, IoT, and UI/UX design. It is followed by Technica, the highlight of Horizon, which features a 48-hour hackathon that inspires around 2,000 participants to excel in creating innovative technical solutions to real-world challenges. The hackathon covers diverse domains, including education, fintech, AI, hardware, and open innovation. Guiding us through today's session, we have Tanishka Srivastava, the Executive Innovations Head, our Executive IoT Head, Saunok, and Ayush Jaiswal, the Executive R&D Head at ISTE-VIT. They will be leading us through different segments of the event and sharing valuable insights throughout. To power your innovation, we are bringing you a live hands-on webinar on room monitoring system using ESP32 and ReactJS, where you will build along step by step. Learn how to connect sensors to ESP32, push live data to Firebase, and display it through a ReactJS dashboard, all in real time. And to keep you all on your toes, we are about to start a riddle challenge in the chat. Your job is simple. Answer as many as you can. We will be tracking all the correct answers answered the fastest. And the big winner reveal will happen once we are done with the webinar. Good luck and stay tuned. To start our session, we have something truly special lined up for you. Welcome, Ayush. He will be highlighting the key features of the ESP32 microcontroller that make it ideal for this type of system, and then walk us through the hardware setup using the electronic components, and end with an introduction to Firebase. Let us give him a warm welcome and get pumped up for an amazing session.
Okay. So, hello everyone. My name is Ayush Jaiswal, and today I'll be presenting a very informative and useful project title called Smart Boom Monitoring System using ESP32, React, and Firebase. This project focuses on real-time safety and comfort monitoring, where we track environmental parameters like temperature, humidity, gas, and flame values to ensure a safer and smarter living space. Okay. So here's a quick look at what we will be covering today. We'll be begin with an introduction to the project and then we'll see what problem it addresses and then we'll go through the system architecture, the hardware connections and followed by firmware integration to the Firebase and then we'll see how React dashboard connects to the Firebase. And finally, we'll have a live demo where we will demonstrate the whole project. And in the end, we'll have a Q&A session to solve your doubts and queries. So this project continuously monitors room temperatures, humidity, gas, and flame values using ESP32 and sends live updates to React dashboard via Firebase platform. And a question will come to your mind like why we are using ESP32? Why not other ESPs or microcontroller boards? So the answer is very simple because it has Wi-Fi and Bluetooth capabilities. It is a very low cost and supports a wide variety of sensors. It has many GPIO pins along with ADCs and DACs and it supports many communication protocols like I2C, UART and SPI. And also it is perfect for IoT based real time monitoring. So we are using this in our project. So here's a quick look at why we need this project. What's the use case of this project in real life? So manual monitoring of room conditions is not practical, and delays in detecting gas leaks, or fire can be dangerous. So there is a clear need of system that provides real-time updates, remote access, and instant alerts. So the goal for today's session is to build a smart, low-cost, and live monitoring system that works 24/7. So here you can see the system flow. First, all these sensors will collect data from the environment, and then this data will be collected by ESP32, and then we'll send the data to Firebase over Wi-Fi, and then Firebase will send this data to a React dashboard, which will be connected using Web API keys and Web app of Firebase. So now we'll go through the hardware components we are going to use in this project. First is the ESP32. ESP32 acts as the brain of the system. It is a central microcontroller which will collect all the environmental data from the sensors. And then we have DST11, which is a digital sensor which collects the temperature and humidity from the environment. And then we have MQ135 sensor, which collects air quality and gas detection of the environment. And it collects data like CO2 and ammonia. And then we have flame sensor or passive IR sensor, which collects, which detects fire or heat in the environment. And then we have LDR sensor, which shows ambient light status of the room. And finally, we'll have a power supply to a battery or USB cable which will be connected to a laptop. So now we'll go through the hardware connection. First, we'll connect DHT11 sensor to our ESP32. As you can see, we have connected the ground and VCC of the ESP32 to the lower bottom terminal of the breadboard, and then we have supplied VCC and ground to the DST11 sensor, and we have connected output of the DST11 sensor to D14 of the ESP32. As it is a digital sensor, so we are connecting it to digital pin of ESP32. And then we have MQ135 sensor, which is a gas sensor. We are supplying power and VCC uh, to the to the MQ135 sensor using this terminal, and then we are connecting A naught of digital of this MP135 sensor, and we are connecting to it to D34 of the ESP32, because it is a analog sensor, so we are connecting it to analog pin of the ESP32. And then we have this passive IR sensor or flame sensor, which is used to detect fire or heat in the room. And we are connecting it to D naught. We are connecting the D naught pin of the flame sensor to pin number 27 of ESP32, as it is a digital sensor. So we need to connect it to digital pin. And finally, we are supplying power and ground to pin to the LDR sensor, and we are supplying D naught of LDR sensor to the pin number 35 of the ESP32, as it is a as it is used to measure the light levels, and we are using it to check the status of light present in the room. So we are connecting it to D naught of the sensor, and it will be used to detect if the light is present in the room or not. Okay. So we are done with the hardware connection. So now we'll set up our Firebase project so that we can provide a backend to our project. So Firebase is a platform developed by Google that provides backend services, cloud storage, and real-time database solutions for building web and mobile applications. In Firebase, we'll set up mainly three components, that is real-time database, mail password authentication, and Firebase hosting for connecting to it to React. So these components will help to store and sync the data. Real-time database will help to store and sync the data which is coming from ESP32. And this Firebase authentication will help to securely access the data. And this Firebase hosting is to deploy the React dashboard. And this Firebase is very easy and reliable to use with ESP32 using Firebase client library, and it integrates with web apps as well. So we'll now set up the Firebase for our project. So I request everyone to open their favorite browser and search Firebase. And now click on this first link, that is firebase.google.com. After clicking on the link, you will be navigated to a tab like this. And now click on Go to Console. Now click on Create a Firebase project. We'll name it as Webinar 10. Okay. Now click on Continue. Then again click on Continue. So you need to choose a account for creating this Firebase account. The Firebase project will be ready in few seconds. So now click on Continue. So now we need to set up the three elements in our Firebase project. close to your current location. So I'm choosing Singapore, Asia Southeast. Now start your project in test mode. Alright. So we have created a real-time database on our Firebase, and then we have to change the rules so that only authenticated users can log in and read or write the data. So here we need to write what what equal to null. We need to copy paste the same thing in the right variable as well. After changing the rules, we need to publish the changes. Okay. So now we need to set up the authentication for our Firebase project. After clicking on authentication, click on get started. Now click on this email and password native providers. Enable both the options and save the changes. So now we need to add a user for this project. So write a valid email and password for your project. So now I have successfully added an email and user. So now we need to go to this project settings and we need to set up a web app for our project. I'm naming the web app as same as my Firebase project, that is webinar 10. So after creating this web app, you need to click on continue to console. Now we have successfully set up our Firebase project, and you will need this web API to integrate your Firebase with your Arduino code. So with this, we are done with the hardware connection and setup of Firebase. So if you have any doubts, you can ask in the chat box.
Wow, what an incredible start. Thank you so much, Ayush, for taking us through that insightful session. Until then, we request the participants to put up the questions in the chat. As there are no questions at the moment, we shall proceed. And now, let us keep the momentum going. Up next, we have Saunok. He will walk us through the ESP32 integration. Let us welcome him with a lot of energy.
Okay, so hello everyone. We will proceed with the with the Arduino program part of our project. So before we start off, we will have to ensure that we have all the libraries installed in order to write our program. So and also we have to ensure that we have our ESP32 board manager installed as well. So first off, you can go to you can open Arduino IDE and then go to the left sidebar over here and click on the second icon. So if you do that, you'll be able to search for your board managers and then just search for ESP32, and over here you'll find a board uh, you'll find a board manager package called ESP32 by Espressive Systems. And if this is not already installed, just click on install, and then it will take 1 or 2 minutes. Not 1 or 2 minutes. It will just take around. It will take less than 1 minute to install your board manager package. And once you do that, you will be able to select your ESP32 board over here, and then you will be able to upload your code as well. And after that, you'll have to go search for your libraries. So you can just click on the third icon over here, and then in your library manager, just search for Firebase client. You will have to install 2 libraries manually. One will be your Firebase client, and the other library will be your THT. So first off, for your Firebase library, you'll have to search Firebase client by Mobist. So this is your official library that allows authentication and database communication from your Arduino IDE to your Firebase server. And you can, if it is not already installed, you can just click on install, and it will take a few more seconds to install as well. So if you're following along, you can just go ahead and install it. And then there is also one more library that you will have to install. You have to search for DHT. So since we're using the DHT sensor, right? So we'll have to install the library to access it, and then you can just search DHT and you can scroll down. And if you scroll down, you can find this library called DHT sensor library by Adafruit. So if it is not installed, just click on install over here. It will take a few seconds to install. And then there is one more library called DHT11. You will have to install that as well, since we are dealing with DHT11 over here specifically. Okay. So once that is installed, you can we will start writing our program right now. So before we include our library packages, we'll have to define 2 variables known as enable user auth and enable database. So what these variables will do is that it will allow our Firebase objects, or whatever objects we define from the library, to allow us to use those objects and functions. So you can just write define enable user auth and define enable database. And following that, we will now start by importing all the libraries that we have installed, as well as the libraries that we will use in our program. So 1 second. And okay, so there are 4 libraries that we are going to use, 2 of which we have installed manually right now. And I'll just close. Okay, so 2 of which we have manually installed right now. So okay, first off, we'll use the Wi-Fi library because we need a network over which our data is being transmitted. And how that will happen is we'll ensure that our ESP32 connects to that particular network for which we are going to enter the credentials for. And then we're also going to use one more library known as Wi-Fi Client Secure. So why we have to use this library as well? Because there is authentication happening in our program. So from the client side, that is from your user side, you will be authenticating into the Firebase server, and this needs to happen over a secure network. So for that, we will have to include the Wi-Fi client secure library as well. Okay, and the other 2 libraries are your Firebase client and your DHT, as I had instructed earlier. You'll have to install those manually, and DHT library will be used to access the functions for DHT, and which will ultimately help you collect the temperature and humidity data. In Firebase client library will provide you with the functions and objects that we require to authenticate and communicate with the database. Okay, and then after that we will have to define some Wi-Fi credentials as well. We'll have to define two credentials: Wi-Fi credentials and your Firebase database credentials. So first off, I'll just define my Wi-Fi credentials. So Wi-Fi SSID, and that will just be my hotspot's name, which is test ESP for now, and define Wi-Fi password. So you will just have to enter your network's credentials and password over here, and then followed by that, you will have to enter your Firebase credentials as well. So yeah. So basically there will be four credentials that we require. One will be your API key. Then followed by that, you need your database URL, and then the email ID and password of the user that for which you have set up the authentication in your Firebase console. So I'll just show that in a minute. So first off, define API key, and that will be under strings as well, and define database URL, and then your user email, and your user password as well. So coming to your API key and database URL, you will be getting this from your Firebase console. So I'll just show that to you right now. So just give me 1 second. Okay. So if you had followed Ayush's instructions, your Firebase console should be set up over here. And then to obtain your API key and database URL, you can just copy your database URL from over here. Like if you go to your real-time database and just click on copy reference URL, it will copy your database URL. And then for your web API key, you can just go to your project settings. And then in the first tab, in the general tab, you will be able to find your API key. So we will just go ahead and copy the both of them. And then we'll have to paste both of these in our Arduino program. So I'll just show that as well. Okay. So just paste your API key, and then you can go ahead and just paste your database URL as well. Just copy that. Okay. And then under user email and password, as you had set up an authentication before, you will have to enter the email ID and password of the credentials that you had set up in your Firebase authentication. So in my Firebase console, I had used this email ID, testuser@gmail.com, and pass1234. But you will have to enter the credentials of whatever user you have authenticated into your Firebase console. Okay, so now that we have defined our credentials as well, we will go ahead and define our sensor pins. So I'll just go ahead and show you. So over here we have defined all our sensor pins into variables as well. So like earlier we had connected these sensors into with our ESP32 during our hardware setup. So we will have to mention these pins into certain variables as well. So if you look at DHT, right? So for DHT you have to mention it as DHT pin, and you'll also have to mention the DHT type, because it will be useful when we have to create the DHT object in order to access the DHT library. Okay, and the rest is same. I think we had connected your gas sensor to 35 and LDR to 34. Okay, and okay, followed by this we will have to define the objects that will access the classes and functions inside the library. So first off, we will just go ahead and define the DHT object. So how we'll write that is library name and then library object. So in this case, I'm just naming the object as DHT, and then uh, give me 1 second. Okay, sorry. As I was saying, we have to create our library objects as well. So we've gone ahead and created a DHT object, and in that we have passed the DHT's pin number as well as the DHT's type that we are going to use. So after this, we have to define some very important. We have to define some very important objects that we are going to use. So first off, it will be your user auth object, which will allow us to authenticate into the Firebase database. Sorry, Firebase server. So you'll do that by just user auth, and then inside that you will pass your API key, your email, and your password. And then followed by that, uh, you'll have to yeah, sorry, you'll have to define your Firebase app object as well, and this will basically be useful to access the Firebase app from your client side. So as you know, the Firebase server has already been created, but it has to be accessed from your user side or client side. So for that, we'll just have to create an object, and we'll do that by Firebase app, and we can name that object as app. So this will allow us to start the Firebase app, or check if the app is ready, or check if the uh, you know app has to stop. So for that we will just define the app object over here that will access the Firebase app from your client side. After that, we will have to define two more objects which are very important. One is your auth client object. One more will be your DB client object. So what auth client will do is that it will allow the user to uh, authenticate into the Firebase server, and then we also have to introduce one more instance that will allow us to authenticate asynchronously. So what does asynchronous mean? Uh, Asynchronously will basically mean that while the user is authenticating, there will be other functions and processes going on as well while initiating the Firebase app. Then during that time, we should not interrupt those processes, or we should not block those processes. So for that, we will have to introduce an async instance as well uh, to enable asynchronous authentication into the Firebase server. So we can just do that by creating an auth client object using the Wi-Fi client secure library, and then using the async client class that is a part of your Firebase library. It will create an async auth instance in which we will pass the auth client object. And similarly, once we have authenticated, we have to enable communication with your database as well.
So for that, we will introduce a DB client object as well. So we can just copy the same thing, but since it's your database, you'll just replace client with DB and async DB, and it is your auth DB. Okay. So these instances will be basically used to allow the user to authenticate and enable database communication asynchronously when we are going to set up the app. Okay. So after this, we'll have to define one last object, and this is very important. It will be your database object. So for that, you can just write real-time database. I'll just name it as database because that will be more convenient. And basically, what this object is used for is like if you want to deal with the data in the database. So if you're fetching the data or if you're sending the data to the database, then we will use this object that we have defined. And in this case, in this project, we are going to send sensor data to the Firebase data, real-time database. So for that, we'll be using this object, and I'll show it to you once we come to that part, right? Once we come to the loop function part. So after this, we have defined all our objects that we are going to use, and now we will have to go ahead and define a Firebase response handler as well. So whenever we are dealing with your Firebase server, you will be, let's say in this case, you're sending data, and then once that data is received by Firebase, you will need a response in return as well. Now that response will not automatically, will not automatically show up in your user side. So you will have to define a function that will fetch that response, and then you can check if that response is an error or if that response is like it gives you a success message response. So I will just go ahead and show you. Okay, so we have defined a response handler function over here called process data, and in that we've passed two arguments, async result and a result. So what is async result? It is basically the class that will ultimately fetch the result. Will ultimately fetch the response given by Firebase after any data sent or received or whatever process is happening. Whatever response Firebase will send, it will be fetched using this async result class, and this result will then be stored into an object called a result. So we will use this a result object to check whatever result is present, or if the result is an error of if the response is an error of or if the response is a success. So as I said, you will have to consider three cases. So one case is that if at all there is a response or not, and then the other two cases will be that if the response is an error or if it is an success. So you'll have to check if the result exists or not. So you'll just do that by the result function, and then you'll check if it's there or not, and if it's not there, you'll just we will just print that there has been no response from Firebase's side. And then coming to the other two cases, we will have to check if the response given by Firebase is an error or not. If it is an error or a success message, right? So if it is an error, we'll just check it using the is function, and then we will print that error message, and along with that, we will also print at what path or at what location that error has occurred. So basically, if you see this aresult.uid, it will return your identifier at which this error has occurred. So let's say if you're sending a temperature data or a temperature value to your database, then if at all there is some error in receiving or extracting the temperature data, then you will get a message, you will get a response from Firebase that at this like for this temperature data, that is your UID will tell you if it is a temperature data or not. So for this temperature data, this error has occurred, so that you will get by your error message. And similarly, for the success message, we'll just check if your result is there in your a result object or not, and then if that is available, then we will just print that as a success message, and obviously we will point it to the identifier as well, wherever that success message is, pointing towards. Okay, and then lastly we will also define two timing variables, and this I will. So right now you won't understand why we are defining this, but I'll to keep it simple, it is to basically make sure that the data is being sent continuously over a time interval of 3 seconds. So for that we've defined the send interval 3000. So since the units are in milliseconds, so for 3 seconds we put 3000. And yeah, once we write our main loop function, that is where I will explain more about why we are writing this. Okay, so I hope there is no doubt in this, defining the objects, credentials, and libraries and all. So I think this should be pretty clear. So we after this we will move forward to our setup function, and in your setup function, uh, it is where you initialize stuff, right? So here we will initialize serial communication, your DHT library, and then we'll also initialize the nature of your pins, whether they are input or output, and after that we will also initialize your Firebase app along with authentication and database communication. So for that we are defining these objects, right? So we'll use these objects in your setup function to enable this authentication and communication. Okay, so starting off, we will have to enable your serial communication and your DHT library, right? So that you'll just do by serial.begin, and for DHT you will use DHT.begin. In serial.begin you will just pass the baud rate that you want your serial transmission to happen in, and then so the baud rate can be anything, but since we are dealing with ESP32, it is good practice to use 115200 because that is more efficient. So okay, and after that we will have to go ahead and use the pin mode function to define the nature of our pins. So we'll just do that by pin mode. And as you can see, since we are using your since we are obtaining data from these sensors, right? Since we are obtaining data from your flame sensor, LDR sensor, and your MQ135 sensor, which is your gas sensor, so we will have to set it as input since we are obtaining the data. After that, we'll just add a print statement saying that the setup has been started. And okay, so now comes a very standard set of a very standard practice, which is your authentication of ESP32 with your Wi-Fi network. So I won't be going into the details of this code, but it is a very standard code. And what is essentially happening over here is that your we will start the Wi-Fi. We will start your authentication of your uh, ESP32 with your Wi-Fi network, right? So for that we'll use Wi-Fi.begin, and then after that till it is okay, sorry. In your Wi-Fi.begin, you'll also pass the SSID and password of whatever network you want to connect to, and then after that we will wait till the ESP has connected to that network, right? So for that we will just use a while loop which will check the Wi-Fi status, and if the status says that the Wi-Fi has successfully connected, then it will come out of the while loop and it will just print uh, the IP address of the local web server that is hosted by your ESP32. So this will enable us to connect our ESP32 to that network. And and the main goal of doing this over here is that we need to send our data over a local network or over a secure network, right? So for that we will have to first ensure that our ESP32 connects to whatever network we are we want it to connect to, and over that network only your data transmission will take place between your ESP32 and your Firebase console. And okay, so after this we will go ahead and do one more thing. We will use the set insecure function. So what this will do is that So what this will do is that basically whenever you want to authenticate over a network, that to whatever server or whatever website you're going to authenticate, right before authentication, it will provide an SSL certificate, and this is required to make sure that whatever user is being authenticated, they're secure under that network. But what we are going to do over here is that we are going to use the set insecure functions so that this process of assigning this SSL certificate is overridden. And why we are doing this is because the user that we had defined over here, right? So this is, I would say, a dummy user that you're just using for your project, or you're just using to authenticate in your project. But let's say if you're going to production grade, let's say if you're going to, industrial level, right? So that time you'll use like authentication providers as well, such as Google or GitHub or whatever. So for such official accounts, you will not have to do this. But since we are using this test user credentials, right, you will have to disable the process of assigning an SSL certificate, because if you don't do that, then the library will handle it as an error and it will not allow your user to authenticate into the database. So for the sake of our project, we will just need this user to authenticate, right? So we will just override that process of assigning the SSL certificate. And if you're building an official product or taking it to like any production level or industrial level, then you don't have to do this. Okay, after all this is done, as we had defined this Firebase app over here, right? So we will have to initialize this app now. So for that, we'll just use the initialize app function, and we'll also have a we'll have a print statement saying that our app is being initialized. And in this initialize app functions, you will pass in 5 parameters. One is async auth, which will enable your authentication process to be asynchronous. And then after that, you will obviously pass in your app object, which will represent your Firebase app that is being started from your client side. And then you will use the get auth function, in which you'll pass the user auth, which will ultimately start your authentication process of the user into the Firebase server. And following that, uh, this will be the process done from your user side, and then from your Firebase's, that is your server side, you will need a response that Firebase will give you as well. So for that, we will call our response handler function, which is your process data, and then whatever response we get, we will assign it to an identifier. So that identifier over here, auth task, can be anything, but over here I've entered it as auth task. So whatever response we get, it will be identified to this auth task string or variable. And then, yeah, that is basically how you initialize your Firebase app from your client side. And then after this, we will have to check if the app is ready. So we will do that by the app.ready function, and we will have to keep calling your app again and again, right, while it is not ready. So whenever your app is until your app is not ready, you will have to repeatedly keep calling your app so that you can start accessing it, right? So for that, we will use a while loop. I'll just show you. So in your while loop, you'll check that if you will put the condition that if the app is not ready, just keep calling the loop, just keep calling the Firebase app repeatedly. And for that, for calling the Firebase app, you will have to use the app.loop function. So until the Firebase app will be ready, it will just keep calling the app from the user side, and once that app is ready, then it will come out of that loop, come out of the loop, and then it will just print that your Firebase app is now ready. So that basically means that the user is authenticated into your Firebase server, and then the Firebase app that is to be accessed from your user side has been enabled as well. So after this, now we have successfully, uh, authenticated into our Firebase server. But our main goal over here is to send the data into its database. So we will have to bind this real-time database into our Firebase app, or with our Firebase app actually. So for that, we will just use the get app function, and inside that you will pass your database object. So I'll just show that to you. And okay, so you will use app.getapp, and then you will have to mention what type of you will have to mention what type of database you are authenticating it to. So since we are using real-time database, we'll just mention real-time database. And let's say if you're instead of real-time database, we're using like Firestore Cloud database or any other database that's present in Firebase, right? So we will mention that instead. In our project, we are using this database, so we'll just mention real-time database, and then we'll pass in the database object for it. And then lastly, we will have to specify to what database it has to connect to, right? So for that, we'll just write database.url, and then inside the function, we'll just pass the database URL that we had defined earlier over here. So your database URL in your API key will basically help to specify on what Firebase server and what what specific database we have to authenticate to or enable the communication. So that is basically what we have done here. We have initialized our Firebase app that we can access from your user side, and after initializing the app, once the app is ready, we will make sure it binds to the real-time database. And for that, we have used your app.getapp, mentioned what database we need to bind to, and then passed in the database object that we had defined earlier. And followed by that, we will have to specify which database. So for that, we will just pass in your database URL using the database.url function. And that is basically your setup function in which you have provided all your initializations of serial communications, your DHT communication as well. Not communication, you have enabled the library. And yeah, okay. So I hope there is no doubt in this entire setup part. It might look a bit huge, but once you go through the code, you will get to know at what each part is doing, right? So in this first part, we are enabling communications and nature of your pins. Then we are just connecting to the Wi-Fi, and after that, initializing your Firebase app, and then finally connecting it to the database. Okay. Now coming to your loop function, right? So this is where you write your main logic of your code. And for that, first and foremost, what we'll have to do is we'll have to, call your Firebase app that you'll access. So I'll just give some space here first, and then app.loop. So this will help us to call that app, right? And under your loop function, as it will, repeat itself continuously. So we will have to just call it continuously as well. And then you will also have to get the time since which the program has started. So for that we'll use the millis function, right? And then after that we will have to put an if condition that will check that if the app is ready and if the last sent data has passed more than 3 seconds. So okay, so let me be clear that we have to continuously send our data over a regular interval of 3 seconds. So for that, we will have to manually check that if the data that was last sent has passed more than 3 seconds or not. So for that, we will just write an if condition that if the app is ready and if the difference between the current time and the last sent time is more than 3 seconds, then all the processes that you define under your if condition should take place. And what those processes are is basically your obtaining and sending of data. So basically, you're receiving the data from your sensor, and you will send that to your Firebase real-time database, right? So that will basically happen once your app is ready, and if the last sent data uh, has passed more than 3 seconds. Okay. So for that to happen, you will first have to, uh, you'll have to create that loop, right? So for that, you will have to assign your last send time. You'll have to update it to your current time, and that will ensure that oh, this process happens continuously and that the time difference it keeps getting updated, right? and after that you will have to obtain. You will have to first obtain your data from your sensors. So the whole process that's going over here is that you're obtaining data from your hardware and then you're sending it to your Firebase real-time database, right? So first we'll go ahead with obtaining the data. So for that I'll just show you. Okay. So first off, as we are dealing with the DHT sensor, right? So we will have to use the read temperature and read humidity function that will be, called with the along with the DHT object. So we'll just write DHT.read temperature and DHT.read humidity, and by doing that, we will get the temperature and humidity values in your variable whatever you will define. So over here, I defined the temp variable. So all our temperature data will store in the temp variable, similarly for humidity. And then for the remaining other sensors, right, you can just use their digital read and analog read functions. And for gas, you're using analog read because it is an analog sensor. That's why. And yeah, that's basically the process of obtaining the data from your sensor. Okay. And one more thing we have done is that we have put an if condition that if the temperature and humidity values are null, then we will directly just print that the data is not being read from your sensor. So sometimes if there is an hardware issue or if there is some sort of typo error in your code, then your temperature humidity values will start returning null values. So for that we've just put an if condition that if that is the case, then we will just print that the sensor has failed to read the data instead of just sending that null value to your database. Okay. And then followed by that, we will just print all this data on your serial monitor as well before sending it to your, real-time database. And okay, now comes the important part. This is where you're sending your data to your Firebase real-time database. And how you'll do that is, this is where the main MVP of your program, right? Your database object that you have defined. This is where it does everything. So how you'll send the data using this is that you will write database dot set, and then first you will specify what data type you're sending. So you'll specify the data type of the data that you're going to send to that real-time database. So I will start with temperature. So I'll just write float, and then followed by that I will have to enter certain parameters, and first will be a async DB. And why I'm doing this is because I want to enable asynchronous communication with your database. And then followed by that, I will have to specify at what path this data has to be stored in your database. So I will just write IoT slash device slash temperature, and this path is optional. You can write anything. If you just write like slash temperature, right, it'll just store in your root. It'll store in your root path. But I'll just write IoT slash device slash temperature, and then once you specify the path, you will have to specify the data. So you'll have to write the variable at which this data is stored, right? So temp is where your temperature data is stored. And once you have done this, you have successfully sent your data to your Firebase. But after that, you will need a response back from your server as well. So for that, again, we will call our Firebase response handler. So that you will just call your process data function, and then you will have to assign this response to an identifier, right? So for that, I'll just write temp ref. So you can give it any identifier. This is just good practice. End it with a semicolon. So yeah, basically you will use the set function to send this data to your real-time database, and for that you will have to enable the communication asynchronously using your asyncdb object, followed by you will specify the path at which this data has to be stored, and then followed by that you will have to mention what data you are sending. So I'm sending temperature data, and that is stored in a temp variable, so I'll just mention that. And then after that you will need a response back from your Firebase server as well. So for that you'll just call the response handler, and then you have to give that response an identifier as well. So that is tempref. Okay. So that is basically a process of sending the data, and I'll just go ahead and do this for the other data parameters as well. Sorry, the other data as well. And yeah. Okay. And over here, one thing if you notice that your flame sensor and your LDR sensor, they're both digital sensors, right? So they'll either give you a high or low output. So what we are doing here is that we are checking if your flame sensor's output is high or low. So let's say if it's high, then we will just print that there is flame. So if the flame sensor's output is high, it obviously means that there is flame, right? So for that, we will just assign a flame status variable that will directly return the status of your flame presence or not. So if your flame sensor says high, your it means there is flame, and we will directly send this flame string to your database. Instead of sending this binary values, we'll just send the status of your flame, right? So that's what we are doing over here, and we use the database.set function as well. Similarly, for your light status as well, if your light sensors, sorry, if your LDR sensors output is high, right? So how that will happen is that your LDR sensors works on a principle with works on a principle such that your resistance will decrease as as the intensity of light increases, right? So what that practically means is that if light is present, your resistance inside your LDR sensor will decrease, and if the resistance decreases, it means that your sensor is tending towards an high state. So again, what that would mean is that if your light is present, then your if your LDR sensor is in a high state, that means light is present, and if it is in a low state, that means if resistance is high, if it hasn't decreased, then it will be there is no presence of light, and for that we will return the dark. We will return the dark string. So we are directly sending the string data over here instead of your binary values. And then lastly, we'll just fill in this tab. And then lastly, after outside your if condition, right, we can just give a tiny delay so that there's a bit of gap between all these processes, right? So I'll just give some delay of 50 milliseconds. And yeah, so that is basically your loop function as well. And again, I'll repeat what we have done. So in your loop function, you have called your Firebase app continuously using the app.loop function, and after that you also obtained the time since which your program has started, right? So you'll do that by the millis function. After that, you will check that if your Firebase app from your to be accessed from your client side is ready or not. Along with, you will check that if the data has been sent, if the last sent data has passed more than 3 seconds. So you'll check both of this, and by doing that, what will happen is that it will send this data continuously over a time interval of 3 seconds. And okay, so once that is checked, it will start obtaining the data from your sensors using the digital read, analog read, and your DHT functions over here. And after that, we will also print this data serially in your serial monitor, and that will confirm that we have retrieved the data from your hardware. And now, once we have retrieved this data, we have to send this data to your real-time database. So for that, we will use the database.send function, in which we will specify the data type, and then we will enable asynchronous communication with the database, along with specifying the path at which this data has to be stored, followed by obtaining a response from Firebase and storing that response at a particular identifier. So that is basically your Arduino program. And after this, you will have to compile the code and upload it to your ESP32 as well, right? So one thing you have to take note of that is this Firebase client library is kind of a new library and is also very big. So it is a really large library. And if you compile it for the first time after writing a code, it will take around 25 to 30 minutes. So once you have done the initial compilation, the second time you compile, it will just take less than a minute. So yeah, you have to make sure of that. And yeah, Okay, I'll just upload the code later on, and I'll demonstrate it after we've created the dashboard as well. So yeah, that is pretty much your entire Arduino program for your project. So if there are any questions, you can feel free to ask in the chat box.
That was amazing. Thank you, Saunok, for that walkthrough. Let us move forward to the first question. That is, why do we need to set the flame and LDR sensor pins as input in the setup function when the DHT pin isn't explicitly set?
Okay, so I think this doubt is for this is over here at this part, right? Okay, so why we are not doing that is because starting off with your other sensors, right? Your flame LDR and your gas sensor, we are directly sending voltage signals to the ESP32 for it to read, and for that we can just use the pin mode function, right? But your DHT sensor is not built that way. It does not work that way. So what why that's good? It is because it is built using the one wire protocol. Now, because of that, you will have to define certain classes, or just define certain functions that will be really large. So for that, we have a DHT library instead, and uh, how we will initiate the pins for your DHT sensor is that we will just create an object, and while creating that object, we will just mention at what pin it is connected along with your type of DHT that you are using. So, so to keep it short, basically because your DHT works on one wire protocol and your other sensors just send regular voltage signals, the way to retrieve these voltage signals from your DHT will differ. So for that, you will have to write certain classes and functions, and that is why we do not use the pin mode function to set the DHT as input over here. So yeah, I hope that was clear.
Thank you, Shanak. Let us move on to the next question. Can we connect multiple sensors to a single ESP32 and still use Firebase only?
Could you repeat that question?
Sure. The question is, can we connect multiple sensors to a single ESP32 and still use Firebase only?
Yeah. So actually, that is what we are doing right now as well. So if you want, you can just if you remove the serial communication, or if you remove the print statements as well. So that is basically what we are doing. We are obtaining the data from the sensors connected to ESP32, and we can just directly send it to your Firebase if you do not want to send it to your serial port. So if you don't want to send it to your serial port, you can just delete the serial.begin initialization over here. But yes, we can just connect multiple sensors to ESP32 and use the Firebase library as well. So, yeah.
Thank you, Shanak. We hope that his valuable insights answered all of your questions. Moving forward, we have Tanishka who will lead us through the React dashboard development. Let us dive in and learn something new today.
Okay, welcome everyone. So first of all, I would like you to make a folder and open it on VS Code. From there, we'll proceed further on the installation of React plus Tailwind CSS. So what I want guys, search on Google React plus Tailwind CSS installation, and the first link will pop up. Open that and you will see a certain screen, alright? After that, here are the commands, and we'll just copy paste it to install React plus Tailwind on a terminal. So you go on View, open the terminal, and paste the command over here. Since I don't want my React app to be named my project, I'm going to change it to RMS underscore frontend. Alright. Now, this installation will take a while since the React app is getting set up. You can see a package.json file has been created. Alright. The installation will take another 2 to 3 minutes over here. So let's just see what are the other things. For the next command is cd and my project. So this is just the change of directory, alright. And then the next commands will be installation of CSS. This line here will help you create a tailwind.config.js file, which will help us in customizing the configurations or any themes or animations we want to add. And this kind of file will be created. You can see its name, tailwindconfig.js, in which we are going to copy paste this portion of the command over here, because normally by default it is empty. Now what does this mean? It is basically telling that in the SRC folders these extensions will have the CSS applied on it. All right. Okay, let's see what the status. Okay, it is still installing. It will take some time. 10, we will have an index.css file also created, in which we will copy these 3 lines of code. And this statement will help you run the server, which will start on localhost 3000. Let's wait for the React app to get installed. It may vary from system to system as well, as it depends on your internet connection. You can see node modules are also here. Okay, some packages have been installed and installing some dependencies now. And in the SRC, you can see your index.css and other files are here. All right. Now you can see index.js. This is the starting point of your React app. You can see here this app component is being rendered. Now what is this app? This is the app.js file. Okay, I'll show you what changes is supposed to be made over here later. Now our React app has been installed. We will change the directory. And we'll proceed with the installation of Tailwind as I told. Okay, after which we will move on to the next command. You can see a tailwind.config.js file has been created over here. Okay, now in this content, we'll paste this. All right. Now we'll copy these 3 lines, then index.css over here, and paste it. So you can see these are giving warnings, but these are not errors. You can ignore them. And then we can do npm run start. Let's see what happens next. Okay, after the loading is done, you will see a React logo over here. Let's just, yeah, so it's here. All right. Okay, so to proceed further, I want you to create a folder in SRC named components. In which I will create a file called dashboard.jsx. Now, here I'll be importing React. There's a yellow line because it has not been used till now. So it is reminding that, okay, this is something that you haven't used. After which I will create an arrow function. With we will be returning some HTML content. Now, I want to import this dashboard in which this arrow function is stored. So I will export it as well by writing export default dashboard. The use of default here is like when you are importing it anywhere else, then you can use any name. Now in app.js, I want you to copy this code mentioned on the Notion page. Now, what is this doing? Okay, so in the code, the components folder is starting with a small c. I'll change it to capital C because I have made it a capital C over here. And I have certain errors because this React router DOM has not been installed yet. So I will write npm I react. Alright, so now what is this doing over here? So this is just the routing on the root page, the root URL. This dashboard component will be rendered. Now what is the dashboard component? It is getting imported from components and dashboard, which is with this file. So this is giving errors since the return thing is empty over here. We will start with the code. So in this step, I will start with creating a nav bar. By class name, you are going to apply the tailwind properties over here. So suppose I want to give a background which has the following hex code. Which is a darker shade of blue. And then I want my text color to be white. And now I will use flex. So base flex helps us to, maintain the elements on our web page in, forms of columns and rows. So I want my elements under this div to be displayed in columns. So I will write flex col, alright? Then I want the content to be in the center, so I'll be using justify center over here. And sometimes what happens due to some extra content or like a white content is there on the horizontal axis, so you get to see a scroll bar and it goes out of the screen size. So to avoid that, we are going to write overflow x hidden. That means overflowing on the x axis will be hidden. All right. After this, I will create another div over here because that was the parent div element. Again, I will give some properties. I'll again make it a flex, then justify center again. Then here, I will provide the height of the screen. I'll tell what MD means. Alright, so here it is. What does this MD means? When I hover over it, you can see that it calls that @media min width is 768 pixels. So from the minimum width of 768 pixels and onwards, this max edge full property will overwrite the default max edge 84 pixels. So this is how we make our web page responsive. Because on phone or any screen smaller, I want this to be the height, and on larger screens like a screen size greater than 768 pixels, I want this to be the height. So for that, MG here means medium screen size. All right. After that, we are going to create another element nav. Now I want to style my nav like this. So basically again flex. Then I want the text to be of medium size. Then on smaller screens, I want text to be XL. Then after that, this is for the medium screen size. And P6. So P6 means padding. Px and Py are padding on the horizontal and vertical axis respectively. But if you write P6, it will be in all the directions. After that, I will write font as mono. So let's start the server and see what is happening. So now you are not able to see that logo because obviously I have changed that, the component which was there already in app.js by rendering the dashboard component. Okay, so now you can see a nav bar which I have created of a dark blue color. All right. After this, I want my nav bar to have images and a heading. So this I'll copy it from here. All right. Now we'll come back here. You can see the logo, the heading are all here. Let's see what all things are mentioned. IMG-SRC here is the link to the ISTE logo. Then alt is one important attribute to be mentioned when we are using the IMG tag, because in case of any broken images or if the site is not able to load the image, it will show a text called icon. Then this is the class name. Again here I have used MD. So this is the width and height that I want to be displayed on the larger screen size, and this is for the smaller screen sizes like for mobile. And I have given a right margin of 4. Then I have a room monitoring system heading in H1 with the top margin of 2. Empty means margin top. And then again I have logo, another logo in the same format. Now what I want to have a neon line on the extremes of my navbar. For that I'm going to use these two. Okay, so now here in this div you can see I have made the position as absolute. Okay, so absolute to the parent div. Width is full because I want it to occupy the entire navbar width, and height to be 1 pixel because I want the line to be very thin. This is the color of the line, and this is the shadow. Shadow will give it a neon effect. Then here I want another bar, so you can see I have added MT20 over here and MT24 over here. So since it's absolute, we need to give a top margin if I want a line to be at the bottom of the navbar. So this margin is for medium screen size and this is for your mobile view. Again, shadow and the background color remain same. Let's see how our site looks right now. Okay, so you can see it's going over here. Let's see what's the error is. Okay, this div is closed perfectly. We'll check for this div. And before that, what I will do, I will just format this code once. And one more thing guys, when you come here, you can see on this page, like I have used certain components over, like variables over here, temperature, humidity, light status, flame status, gas level. So this is hard coded right now because I have not integrated it with the Firebase. So when Saunok will tell you the Firebase integration, he will change these values to the real-time values. But for now, we will hard code it. So what I can do, I can just copy this and I will paste it in the, alright. Now see, I am getting so many warnings that these variables are not yet used. So that is fine, we are going to use it anyways later. Fine. So now, this is how our site looks. Then we'll proceed further. Okay, so now I want 5 boxes to, display temperature, humidity, gas level and everything, the room is getting monitored by. Okay, so this is the code for your temperature box. We'll copy this. And we won't type it after or paste it after this div because this is your parent div. So just after this div, we are going to paste this code and let's see what does it say. From here, it's being copied. So now I want the background below the navbar to be black. Flex. This is the height. And now justify around. It means like it will occupy the contents, whatever contents are there. It will readjust itself to the space around it. All right. Then we have another div which says flex, flex hole, and MT6. Now so many divs are there because I want many rows, and in those rows I want certain columns. So first of all, I want all the elements under this div in columns, and then this div means you can see I have written MD flex row. So in the desktop view, I want the things to be displayed in a row, and when it comes to your mobile view, I want it to be displayed in column. So this is flex code, and then that is what we are changing with MD over here. Your space by 14 is the spacing on the vertical axis, and this vertical axis I am making it 0 when it comes to larger screen sizes. The same is done with the horizontal spacing. Okay. Now you can see this is the width height of the whatever div element I am making. On medium screen size it will be this, and you can see rounded full, so it will be a circle. Okay. Border is 4 pixels and this is the color of the border. Alright, this is the background inside that circle. This is the transition, and then relative is your position, and you can see shadow effect is also there, so it will also have a neon texture. Item center will place your, whatever content is there in the center on the vertical axis, and justify center will make it in the center of the horizontal axis. All right. Now on hover, it's written translate y2 and cursor pointer. Let's see what does it mean. Now when I put my cursor over here, you can see it's getting translated on the y-axis, and from this pointer it's changing to a hand thing. So that is known as cursor pointer. So on hover, I have added these effects. Then you can see one more thing. Okay, so now temperature is written in curly braces. Why? Because temperature was a variable. So if you just write temperature without curly braces, it will just display the temperature instead of the value of it, that is 32 over here. So we use curly braces. Now we have another div which says absolute inset 0, and most of the things are same. So you can see a small circle over here, alright. So what it is doing, inset 0 means it's a shorthand property which says top, left, bottom and right, everything is set to be 0. Like it will be very close to its parent element. It's also rounded full. It's a circle, but why are you seeing only a portion of it? Because I have made the border transparent now, which is being overridden by border T-pink. That means only the top portion of the border will be pink and rest of it is transparent. And you can see I have written animate spin slow. So now to configure this, we are required to make certain changes in our tailwind.config.js, as I said. So you can find it over here. We'll copy this, and in the extent we are going to paste it. Okay. Let's see how our site looks now. You can see now it's moving. So this was the spin animation that we have used. Alright. Now let's move on to the another box. Now this will be your humidity box. You can see most of the things are similar except for this portion where I have written M rounded S full and rounded R null. So this means the box will be round on the start and it won't be rounded at the end. Let's see how does it look in our code. Okay, so let's go back to dashboard.jsx again, and here I'll paste it. Let's see how it looks. Okay, so you can see it's rounded on the start, but it's not, rounded at the end portion of it. Let's see the code for more things. Okay, so this is your color of the text. This is your font size, font color. Okay, these are spacing, margin left, margin top. Okay, so this is quite, suggestive of its name that what is it doing. Again, we are writing the humidity. Now, how are we getting that range? We are using input type range, and then the value is being passed at humidity. So this seek you are seeing over here is getting adjusted to this value. All right, fine. Then you can see hidden MD flex and current moisture level. What does it mean? So I told you whatever is written in MD will, this display flex will be overwritten. It will override the hidden thing. This is by default in your mobile view. Like current moisture level won't be displayed in your mobile view, and it will be visible on your laptop or any larger screen size. Let's see. We'll go and spec and we'll reduce it. Okay, so you can see you can't see current moisture level over here, and this box has also been changed to a circle. So how is it happening? Okay, so you can see over here I have written MD rounded full, S full, and MD rounded R none. But before that I have written rounded full. So that means this is the default view, and on larger screen sizes only it will change to this. Okay, so we are done with the second box as well. Then we have our gas level box. Let's see how our web page looks right now. Okay, so this also has similar properties. So it's just a repetitive styling of the above box. Okay, now next I want my another elements to be in the next row. Since this row has been occupied, I want things to be here. So what I will do, I will search for the div which had flex row, which is this one. And after this, I'll be pasting the other box codes. Alright. So I'll just enter over here. And then let's just move to light status. We'll paste it over here. Okay, so our site looks like this right now. See, rest of the code is very repetitive, like spacing, how I have made it responsive. The new thing over here are these ternary conditions. So it says that if light status is equal to light, then after the question mark, whatever is written, that will be true. And if not, after the colon, what is written, that will be true. So you can see the status of light, since it's dark right now, and here it is checking for light. So you can see a dark brown background without any gradient and a shadow. All right. Now, if I change this to light, you can see there's a gradient and this also has started to glow. So you can see here in the ternary operators, it's written the same thing, that background gradient to right, that means it will be a gradient from left to right. The colors are given, like what colors are getting changed, and a shadow effect. All right. Same thing is being done with the sun emoji over here, like what will be its opacity, how will the shadow be. Okay, so the same things. Fine, let's move on to another box, which we have as flame status. We'll paste it over here. Okay, so it's the same. If I change it to flame, this will glow, and the background will also be a gradient one, since we are using the same ternary condition application again. Okay, if I inspect it, you can see everything is a circle because I have coded it that way. All right, fine. So this was your ReactJS dashboard, a fully responsive ReactJS dashboard. You can go ahead and ask your doubts.
Thank you, Tanishka, for this amazing session. The first question is, what is the use of tailwind.config.js?
Okay, so basically it's a file that is used to, customize your Tailwind CSS by defining the theme settings, animation, whatever customized things you want to add to your CSS file, you get to, add in your tailwind.config.js. Suppose if I wanted to add some font, or if I want the 3XL size to be changed to some other pixelated thing like 76 pixel or anything else. So that will be done in this file. For example, I used it in animation. I wanted to add animation spin slow. So I added that in the extent and I pasted the code over here. All right. I hope I was clear.
Yes, thank you so much. Moving forward to the next question. Why are we using React here?
Okay, so we are using React because its syntax is easy, and like you can see, it's so much better than HTML in case of rendering stuff. And like it was a very basic code here. Right now we have many more libraries of React. There's chart.js. There are so many things over here. So that makes our work easier. If I wanted, these variables or the data, the live data of coming from the room to be displayed in form of a graph or any other thing. So we have many inbuilt libraries in React because it's a framework. It's a JS framework, so it has many libraries, which makes the developers work easier.
Great. Moving forward to the last question, that is, why do we use arrow functions in React?
Okay, so arrow functions, in simple terms, I would frame that it's used to have a shorter and cleaner syntax because they don't create this keyword, like in quote I will say this keyword, they don't create their own this keyword, so it has a very simpler and cleaner syntax when it in comparison to the regular functions. That also avoids common binding errors in React. All right.
Oh, great. The next question we have is, could we use React without Tailwind CSS?
Yeah, of course. Like I chose my tech stack to be, tailwind.css, but you can always make a style.css file and link it. All right.
With all doubts being cleared up, let us welcome Saunok again to explain us how to integrate Firebase with React Dashboard.
Okay, so before I go ahead and start, the integration of Firebase with your React dashboard, I will just show you how the data looks like when it's being sent. So this is your hardware setup, right? So you just power it with your USB cable, and it's working. It should start glowing along with all the sensors over here. And then if you look into your Arduino program as well, you can see that first it will connect to your first your ESP will make sure it's connected to your local network. After that, it will start initializing the app. So for that, we have defined the while loop, right? So once that app is ready, it will find that Firebase app that you're accessing from your client side with your real-time database. Once that is done, in your loop function, your data will be obtained and it will be continuously sent to the database. Along with and once it is sent, you will get that Firebase response saying success. And as I had said earlier as well, in the Arduino program, it will it will return at what data this success has occurred. So for each, so it will, the response handler will give you that success response as well. And then I will go ahead and show you the Firebase real-time database as well. This switch my screen. One second. Okay. As you can see, your real-time database should look something like this. And then if you look at the data path, at this particular data path that we have specified earlier, we are um, getting all our data, and it is being updated every 3 seconds as well. So that is basically your transmission of data from your hardware to your database. And now what we will be doing is that we will fetch this data from your database, and we will we will integrate it with your React dashboard that you had just built. So I'll just go ahead and share that to you. So okay, if you have followed along what Tanishka had instructed, your dashboard should look something like this. And now what we'll first do is we will remove all the hard-coded values over here, and then what we will have to do is we will have to install the Firebase library. So for that, you will have to open a new terminal, and you will have to make sure that you are in your current directory as well, and then just type npm install Firebase. What this will do is it will install the Firebase package that we require for accessing all the functions and the objects you need for authentication and database communication, right? So now we will we have successfully installed your Firebase library, and we will go ahead and start integrating Firebase in our React dashboard. So first what we'll do is that we'll import the app, or we'll import the app object, right? So we need to access the app from your client side. So for that, we will first import this function, initialize app from your Firebase library. And obviously, you will mention from where, so like Firebase app, right? And then for your authentication as well, you will import it from Firebase/auth. So you'll import get auth from Firebase auth, and along with this, you'll have to uh, import one more function as well, which will allow your user to sign in, right? So that will be a sign search for it over here. Sign in with email and password. Yeah, sorry. So you'll have to search for this, and then after that we'll have to import the database objects and functions as well. So for that we will import get database. database update. Yeah, and along with this, you'll have to import two more functions as well that we are going to use. One will be your onValue function, and one more will be your reference object. So onValue and your reference. These are sorry, these are very important functions that you will have to import so that we can extract the data that we are going to fetch from our Firebase real-time database. So, okay, now that we have done this, we will have to access our Firebase server, right? So for that, we will have to initialize the Firebase credentials that we will require to authenticate into our particular Firebase console and our database. So for that, what we will do is that first we will go to the root directory of our folder. So for that, you can just click on any of the files over here. I'll just click on package.json, and then I'll have to create a new file. And what file you're going to create over here is your .env file. And what this file will do is that it will store all your environment variables that you'll be using in your program. So what I mean by environment variables is that your secret credentials, right? So all your database credentials, your Wi-Fi credentials, and all these credentials should not be exposed in your code that you're going to publicly show to people. So for that, you'll need to create you'll need to create a .env file, right? So you can just go ahead and create that over here. Since I've already created one, I'm not going to create it right now. And as you can see in my .env file, I'll have to import all the Firebase server and database credentials over here. So how you'll do that is you will write React _app _ whatever credential you're going to import. So since you're using React, this is the format that we have to follow. And the credentials that you'll enter, like your API key, your database URL, and all of that will have to be under a string. So you can just go ahead in your project settings in your Firebase console, and you'll find all of the credentials over there. I'll just show that to you as well right now. Okay, so as you can see, your console should look something like this, and then you can just go to your project settings over here, and then under the general tab, as you had created your web app earlier, if you just scroll down, you can find that the default configuration is in Node anyways, and you can just go ahead and copy all these credentials one by one, and then paste it in your .env file and store it as environment variables that you will be using in your dashboard component, right? Okay, so coming back over there, one second. Okay, yes, so as you can see, you have to one by one copy and paste your credentials over here in your .env file. And after you have done that, you can go back to your dashboard file, and then you can just import these in your Firebase config variable. So that is a constant variable as well, since we're not going to change that. Config, and then I'll just go ahead and paste all of this. Okay, so as you can see, the way you access the environment variable from your .env file is that you write process.env and then the environment variables identifier, or the variable name. And yeah, so basically this will point towards the API key, this will point towards the auth domain ID, and this will point towards your database URL, and all the respective credentials for each of these configuration details. Okay, so after this we will have to initialize our Firebase app as well, right? So for that, what we'll do is we'll initialize an app variable, which is obviously a constant again, and then we will just write. We'll okay. So we imported this initialize app function, right? And if you can remember, we wrote this in your Arduino program as well. So I'll just do that initialize app, and then I will pass in the uh, Firebase credentials in this. So Firebase config. So we've stored all the credentials in this, right? So I'll just pass that over here. And then followed by this, we'll have to, create a authentication and, uh, okay, we'll have to create two more objects. One will be used for authentication, one will be used to enable the database communication. And basically, in this case, that will help us to retrieve the data from your database. So for that, you'll have to write const auth equals to your get auth, the function that we imported, get auth. Inside this, you will pass your app variable, and you'll do the same thing for your database. Database equals to get database and app. Okay. Okay. Then after this, what we'll have to do is we'll have to allow the user to sign in, right? So for that, we will be writing a sign in function as well, and inside that we will be using this sign in with email and password function that we have imported from your Firebase library. So I will just go ahead and show that. Okay, so first off, there's a typical async await function written in JavaScript that uses a try catch method, and we have just defined the function name as sign in with email password. This should not be confused with the function that is being imported from Firebase, that is your sign in with email and password. Okay, so right, so we use the async await function over here. Inside your try method, you just call that function, and then you will authenticate, or you will authenticate whatever user you're trying to authenticate inside that Firebase server. So like in my Firebase console, I had defined these user credentials, right? And with these user credentials only, I was able to send the data to your Firebase. So now I will be using the same user credentials to, uh, access, authenticate into the Firebase server from the user side, and I will pass in the auth object as well. So what this will do is that it will start the authentication process of the user into the Firebase server, and it will also do it asynchronously. So as we had done the same thing in your Arduino program as well, over here also we'll have to do it asynchronously. And again, why why we are following asynchronous method is because we don't want the other operations that are taking place to be blocked. Asynchronous operations are non-blocking, right? And then after that we just this is optional, but we just print in the console that once the user has logged in, we will just print it as like the user has logged in with those credentials. And then let's say there's an error, so for that of course we use the catch method, right? And we will just print the error in the console as well, saying what the error is. Okay, and yeah, and by the way, this should be inside your dashboard function, and all of this has to be outside it. Just keep that in mind if you're following along. And okay, after this, what we will do is that now we will go ahead and use uh, two of the most well-known hooks in React. So hooks is something that is very exclusive to React, and very exclusive to React. Sorry, and what it is basically it is a set of functions that allow the manipulation or the management of states or behavior of the component once it is rendered. So over here we will be using two hooks. One is your use state and one is your use effect. So right now we will use the use state hook, and what it does is that it will manage the state of your component or your variable to whatever you assign it to. So as you had earlier hard coded those values, right? Temperature, humidity, your gas level, flame status, So all this was hard coded, but now we will fetch this data from your database, right? So there is a gap between fetching this before fetching this data and after fetching this data. So that will basically mean there are two states of that data. So what we have to do is we have to set an initial state for it. So that would mean that before the data has been fetched from your Firebase, it will it will be in its default state, or it will print something before that, and after the data is fetched, it will switch into that second state. So what that is it will be your updated state, which will have the updated value. So I'll just type it out over here and it will be clear. So how you have to do that is const temperature, and then to update your state, you'll have to set a set temperature variable as well with your T capital, and then you'll have to use the use state hook. And okay, one more thing is that you'll have to make sure that it is imported over here. So I'm using an extension for got auto imported, but you have to make sure that go to your first line of your code, then right next to import React, just import your use state as well, use state hook. So you'll have to use that hook over here. And now, as I said before retrieving the data and after rendering, it has to be in a certain state. So I'll just give it as loading, and then you'll go ahead and do this for all the other data variables as well. So I'll just show that. One second. Yeah, sorry about that. So as you can see, we are importing the data variables of the other data as well. So gas level. Okay. So yeah, so what this is doing, that basically after the component is rendered, that has this variable, right? It will initially print loading, and after this, what we will have to do is that we will go ahead and use the use effect hook. Now, when is the use effect hook used? It will be used when uh, you have to manipulate the functionality, or basically you have to whenever you have to manipulate the functionality of a component once it is rendered. And best example would be like if you have worked with JavaScript DOM manipulation. So when you're working with in regular vanilla HTML CSS JavaScript, you just write all the functionalities in a separate JavaScript file. Whenever you're working with React, you can do all of that under the use effect hook, because as I said, it will be used to manipulate the functionality of a component after it is rendered. So okay, so how you write it is, first you write use effect and then pass in an arrow function inside it, and followed by that you will have to return an empty array along with it. So what we have to do is that so we'll have to check if the user has authenticated into the Firebase, right? So that for that we have this function called sign in with email password. So we will, using this function, we'll check if the authentication was a success or not. So if it was a success, so sign in with email password. So you have to call the function over here, right? So sign with email password. If it is a success, then all the following operations will have to take place. So this is an arrow function as well, by the way. Okay, and let's say if it is not a success, then it will just return nothing. it is not, if it is not a success, we'll just return nothing, right? So okay, after this we will have to store the data in variables, right? So we'll have to store the data. What data this is, right? So okay, this data is basically your data that you'll fetch from your Firebase real-time database, and you will have to store this into reference variables. And for that we will just write const temp ref. So this is the reference variable for your temperature data, right? So now we will use the function that we imported called ref over here. So your reference function, in which you will pass the database object that you had created, and then you will specify the path at which this data is stored. So if I want temperature, it was stored at IoT/device/temperature, right? And similarly, we'll go ahead and do this for all of the other data variables as well. So I'll just show that to you. Right. So all of this data will be stored at this reference variable, and for that we are using this reference function, in which we are passing the database object that will allow us to connect to the real-time database, and you'll specify the path at which this data is stored. Okay. And now after this, you will have to use one more function that we imported. So if you follow along, we have used every other function and object that we imported. Now we only have to use this onValue function, and this is also a very important function. And what it will do is that it will basically fetch your data from your Firebase, right? So for that, first we'll call it, and then we'll have to enter whatever that data's reference variable is. So over here for temperature, you define tempref, and then followed by you will define an arrow function. And in this arrow function, you'll have to give in a parameter as well. I'll just give the parameter a snapshot. And after this, what this will do is that it will basically store this data into a local variable that will define. And once this data from the Firebase is stored in that variable, we will update the state of this data, right? We'll update the state of the data that has already entered to that new data, which will be stored in that local variable. And okay, I'll just show you what I mean. So once data equals to snapshot, snapshot dot val function. And what this val function will do is that once it fetches that data at that particular path, right, it will have to extract that data so that it can store it as whatever format it is. So float data, will store it as float inside this local variable called data. So after that, we will check if this data is empty or not. So if data is not equal to null, so that means if the data is present and the data is the data that we want, then we will just update the state of the data. And what that means is that from loading, it will go to like 32 degree, 33 degree, will start showing the data that it has obtained from the database. So that is what you are doing over here, set temperature data. That will be used to update the state of your whatever data variable is there, right? And okay, we'll go ahead and do this for the rest of our data as well. So I think that's 5, right? So light, and then set light status, name, set flame status. Similarly, we'll do it for humidity as well. And for lastly, for your gas levels as well. Gas, set gas level. So yeah, that is basically it. And over here, what we have done is that using the onValue function, we have passed the reference variable at which points towards the location of the data, and then using the parameter will it will point to the data, and that data will be extracted and stored into your this data variable, which is a local variable inside the function. And then once that is obtained, we will update that data to a new state of your current of your data variable. So that will basically enable it to update the data. And since we are sending the data in your Arduino program every 3 seconds, right? That means the data is being updated every 3 seconds. And what this will basically do is it will enable that real-time monitoring feature as well in our project. So that is basically our entire integration with our Firebase. And now we have successfully integrated the dashboard that we created with your Firebase as well. And now what we will do is that you can save your file, and then we can go ahead and run your run your dashboard. So for that, since we're using React, we'll go ahead and write npm start, and I'll just show you how it looks like. Mm, okay, great. Just share my screen. And as you can see, our server is starting, and then will be hosted at port number 3000. It'll take a while. So meanwhile, you'll also have to make sure that your Firebase console is online and it is not offline. And as you can see, our front end server is loaded. It is a bit slow. Yeah, just reload it. So I think there is an error. 1 second. There is no error that should prevent rendering. Just I'll try to start the server once more. Wait 1 second. Okay. So I just restarted my server once more. I think it was a net issue. right? So I'll just go ahead and reload it. As you can see, the initial state is loading, and once the user logs in, it will start fetching the data from your Firebase and it will update it over here. And yeah, so as you can see, we have successfully integrated your Firebase real-time database with your web dashboard that you have built. And then you can then after this, what you can do is like you can go ahead and host your dashboard uh, in any hosting platform, right? So you can just deploy it over there, and as it is a responsive website as well, you can just monitor your room through your phone as well. So uh, that is our entire dashboard, and I'll just go ahead and summarize the program what we had done earlier as well. So as you can see, first we had in our Arduino program we had defined all the libraries, credentials, objects, and then we also had to define a response handler. And after that, we had to initialize all the communication, serial communication, which is optional. And then you had to initialize the pins, and after that you had to make sure that your ESP connects to a Wi-Fi network, right? And one more thing to note is that your data transmission will only happen if that ESP and your laptop that will power your ESP is connected to that local network. And once you upload your code, you can power your ESP using any power source, using a power bank or something, and it will still work as long as that network is there, in its presence. And once it is connected to the network, like it will initialize your Firebase app, and once your Firebase app is initialized, it will connect the database as well. And yeah, after that you'll have to continuously call your app, and then you'll have to make sure that once the app is ready, you should also make sure that the data is being updated every 3 seconds. And inside that, you will obtain all your data from your sensor, that is your hardware connection. After you have obtained it, you will just print it in your serial monitor, ensuring that all this data has been has been obtained. And then after you have obtained the data, you'll send it to your Firebase. And then once you've sent it, you will go create your React dashboard. And in your React dashboard, you will just uh, you know integrate it with Firebase such that it authenticates into your Firebase app. And then after authentication, it connects with the database. And then you set the default states for your data as well. And once a user is authenticated into Firebase from your React side, after authentication, it will fetch that data from your database. And once it is fetched, you will get something like your um, real-time monitoring system as well. So yeah, that is pretty much our room monitoring system as well, built with ESP32 and ReactJS, and it follows your real-time database that is contained inside your Firebase. And yeah, that pretty much wraps it up.
Thank you, Saunok, and a huge thank you to all of you for being such incredible participants today. You have built something awesome, and I hope you have enjoyed every step of the journey. Before we take questions from the last session, please click on the link in the chat to mark your attendance. Also, we would really appreciate it if you could fill out the feedback form. The link for the same is in the chat. It helps us improve and plan better events for you. Seems like there are no doubts. As we come to the end of this incredible event, I would like to express my sincere gratitude and a huge thank you to our esteemed faculty coordinators for their unwavering support and guidance, which made this event possible. A special mention goes to the core members of ISTE-VIT who worked tirelessly behind the scenes to ensure everything ran smoothly. Thank you, everyone. Finally, let's give a round of applause to our outstanding speakers, Ayush, Shanak, and Tanishka. Your insights have enriched our knowledge and engaged us all. Okay, the moment you all have been waiting for is finally here. We have counted up the correct answers to crown our riddle champion. Let's get a virtual drum roll in the chat, please. And the winner is Samanyu. Thank you so much for being such a wonderful audience. We really appreciate your time and attention. Again, filling up the attendance and feedback form is mandatory, so kindly navigate your way to the link present in the chat and do the needful. Thank you once again, everyone. We look forward to seeing what you create with the skills you have learned today. This is your host, Sahani, signing off.